Hello guys, my name is Bino, and in this video we'll be focusing on question 1 from the April 1st 2020 and for mathematics question paper. Question 1.1, we have to simplify 90 minus x multiplied by sec of 360 minus x, all divided by cot of 90 minus x multiplied by sine of 180 degrees minus x multiplied by cosec of 180 degrees plus x. So let's rewrite this trigonometric term. So we have 90 degrees minus x multiplied by 1 over, so we know that sec of x will be equals to 1 over cos x, and cot of x will be equals to 1 of tan x, and cosec of x will be equals to 1 over sin x. So this sec, we can express it as cos of 360 degrees minus x, and this cot we can write it as 1 over tan 90 degrees minus x. The sine of 180 degrees, we just leave it as it is, and the cosec we can write it as 1 over sine of 180 degrees plus x. We know from our trigonometry that we have this, all of these sine, cos and tan are positive this side, but only sine is positive on the second quadrant, and tan on the third quadrant is the one which is positive, and the cos, only the cos is positive on the fourth quadrant. So if you want to remember this, you can remember it as the cast diagram, or all students take coffee. So we have sine of 980 degrees, so we have 0 degrees here, 90 degrees, 180 degrees, 270 degrees, and 360 alongside the 0 degrees. We know that we have sine of 90 degrees here, so the 90 degrees is here. Anything that you minus it with, so in this case the x will be less or equal to 90 degrees. So when you minus this 90 degrees, it will fall on this first quadrant, and sine on this first quadrant is positive. All of them are positive, but sine 90 minus x, we can write it as cos x because of our complementary angle. So if we had sine of 30 degrees, this is equals to 1 over 2, and when we minus 90 from this 30 degrees, we also have to change from cos, so that cos 90 minus that is also equals to 100, is also equals to 1 over 2. So because of our complementary angle, we have to also change this sign and write it as cos, and from here cos of 360, so 360 is in this quadrant, so from here up until there is our 360, and cos is positive, so we'll have cos x without any negative number, all divided by 1 over tan. So tan 90, so all of them here are positive. 90 minus x, and x is less than 90, so all of them will be positive here, including the tan. So we just write tan x, and we also have the sine of 180 degrees. So 180 minus anything, it will lead us that side, and that side sine is the one which is positive, so this will be positive sine x 1 over, and this side we have 180 plus, so 180 is here. When you plus it, it's gonna fall. When you plus it with any angle which is less than 90 degrees, it's gonna fall in this quadrant, and only tan is positive, so we write our sine as negative sine x. So from here we have, so we can rearrange that as cos of x divided by 1 multiplied by 1 over cos x, and we have 1 over tan x multiplied by sin x divided by 1 over negative 1 over sin x. So that cos x will cancel out with that cos x because of that multiplication sign, and because of this multiplication sign as well, this sin x will also cancel with that sin x, and we'll be left with 1 on top divided by 1 over tan x. So this negative 1 multiplied by that 1 will also be equals to negative. So we have 1 over tan x, which is also equals to negative tan x. Remember when we said a over b over c, this is equals to a multiplied by c over b. So 1 over negative 1 over tan x is equals to negative tan x, also with that sign. Question 1.2, we have to solve for beta if 2 cos squared 2 beta plus cos 2 beta minus 1 is equals to 0, and beta has to be between negative 180 and 180 degrees. So in order for us to make things simple, let's let cos 2 beta equal x. So where there is cos 2 beta, we'll substitute x. That cos 2 beta is raised to the power 2. We also raise this x to the power 2, and we replace that cos 2 beta with x. Minus 1 is equals to 0. From here we solve for x. The factors of 2x squared is 2x, and x, the factors of 1 are 1 and 1. The numbers that you can multiply in order to get that 1 is 1 and 1. And we have a positive x here, so we have to put that plus there and that minus here. This negative multiplied by that negative will be negative 1 multiplied by that x will be negative x, and this 2x plus that multiplied by that 1 will be equals to 2x, and negative x plus 2x is equals to x, and we have x there as our middle term, so this is equals to 0. So 2x minus 1 will be equals to 0, or x plus 1 will be equals to 0. So we solve for x. This negative 1 to the right is going to change sign from negative to positive. We take this 1 to the right, it's going to be negative 1. So we divide both sides by 2 so that that 2 can cancel out with that 2, and x will be equals to 1 over 2, or x will be equals to negative 1. So we said that x is equals to cos 2 beta. So in the place of this x, let's substitute back the cos 2 beta because we have already simplified that equation. So we have cos 2 beta is equals to 1 over 2, or cos 2 beta is equals to negative 1. So we remove this cos by introducing the arc sign on the right hand side, arc sign of 1 over 2, or 2 beta will be equals to arc sign, arc cos I meant, of negative 1. So 2 beta will be equals to arc cos of 1 over 2 is equals to 60 degrees, and 2 beta is equals to the arc cos of the negative 1 will be equals to 180 degrees. So we divide both sides by 2 so that we can get beta alone. So that 2 will cancel out with that 2, and beta will be equals to 60 divided by 2, which is 30 degrees. That 2 cancels out that 2, and beta will be equals to 180 degrees over 2, which is equals to 90 degrees. So you take this 30 degrees, you substitute it into this equation, you should be able to get 0. And this 90 degrees as well, if you want to check if these answers are correct, you take this 90 degrees, you substitute it into that equation, it should be able to give you 0. Question 1.3.1, derive the identity for cos of x over 2 if 1 minus an x is equals to 2 cos squared x. In other words, we have to make cos of x over 2 the subject of the formula. So we have 2 cos squared x over 2 is equals to 1 minus sin x. So we have to make this cos of x over 2 the subject of the formula, so we have to divide both sides by 2 so that that 2 can cancel out with that 2, and cos squared x over 2 will then equal 1 minus sin x over 2. We have to get rid of that square, and to get rid of any square we introduce the square root. And immediately when we introduce the square root, we also have to include the plus or minus sign in front of the square root. So the introduction of that square root will cancel out that square. So cos of x over 2 will be equals to plus or minus the square root of 1 minus sin x over 2. Question 1.3.2. Determine the value of cos of 15 degrees without the use of a calculator if 1 minus sin x is equals to 2 cos squared x over 2. By the term without the use of a calculator, they mean that we have to use special angles. We were channeled to make this cos x over 2 the subject of the formula for a reason. We have cos of x over 2 here, and we're also given that cos of 15 degrees. And in order for us to not use a calculator, we have to use special angles. And there are only a few special angles that we can use here. So we have 30 degrees, 45 degrees, or 60 degrees, 90 degrees, and the rest are too far from this 15 degrees. So we are given this x over 2, and we are also channeled to use that 15 degrees. So if we were to say x over 2 is equals to 15 degrees, so we are given this cos of 15 degrees and this cos of x over 2. That's why we are saying x over 2 is equals to 15 degrees. We make x the subject of the formula by multiplying both sides of this equation by 2, so that 2 will cancel out with that 2, and x will be equals to 15 multiplied by 2, which is equals to 30 degrees. So we have cos of x over 2 is equals to plus or minus 1 minus sine of, so in the place of that x we will substitute this 30 degrees, because we figured out that through that formula that x is equals to 30 degrees over 2. So now we are able to use that special angle. So the sine of 30 degrees is equals to 1 over 2 plus or minus the square root of 1 minus 1 over 2 is equals to 1 over 2 divided by 2. We have 1 over 2 divided by 2, so that 1 over 2 divided by 2, we are trying to simplify 1 over 2, so this is divided by 1. So we introduce this multiplication sign instead of that division sign, and when we do that, this numerator will become the denominator, and this denominator will become the numerator. So this will be equals to 1 over 4. So this is equals to plus or minus the square root of 1 over 4, which is equals to plus or minus 1 over 2. So cos of x over 2, cos of x over 2, cos of x over 2 is equals to plus or minus 1 over 2. Question 1.4, we have to prove that sine of x plus sine 2x divided by 1 plus cos x plus cos 2x is equals to tan x. So in order to evaluate this trigonometric identity, we have to use our formula sheet. So this sine 2x is equals to sine 2 of sine x plus cos x. Let's try to figure it out from our formula sheet. So from our formula sheet, this is the formula that we will use. This sine of a plus b is equals to, so this will be replaced by x, so a will be x. So this sine 2x, we can write it as sine of x plus x, and from there we will use this formula over here, sine a plus b, but a will be equals to x and b will also be equals to x, and we replace x here, x here, x here, x here. These two will be the same, and we will add them, so there will be 2, so we'll have 2 times of these things. That's why there we have 2 sine cos x. So this sine cos x will be that one, and the other sine cos x will be that one. So when you add them, they will give you 2. This will be divided by 1 plus cos x plus cos 2x. Same thing, we'll use this one instead of that one above, but x, a will be equals to x, b will be also be equals to x, and we'll have x and x here. So cos x multiplied by cos x will give us cos squared x. So we'll have cos of x plus x, and from there, so we had a positive, we had a plus, so we had a plus, so on this formula this was supposed to be minus plus. So if you have a plus here, you'll have a minus that side. If you have a minus here, you'll have a positive that side. So this will be cos squared x minus sin squared x when you substitute a for x and b for x, and you use that formula. So we'll have sine of x plus 2 sin x cos x, all divided by, so let's not write that one for now. Let's write this cos x plus, we write that cos squared x, and then now we write this one plus 1 minus sin squared x. We also use our formula. This time around we'll use that first one. We'll use that sin squared x plus cos squared x is equals to 1. So from here we make this cos squared x the subject of the formula by taking this sin squared x to the right. It's going to change sign from sin squared x to negative sin squared x. So we have 1 minus sin squared x. Here we'll replace that by that cos squared x. So we have sin x plus 2 sin x multiplied by cos x, all divided by cos x plus cos squared x, and in the place of this 1 minus sin squared x, we'll replace with that cos squared x. So from here we have sin x plus 2 sin x multiplied by cos x. We have cos x, so now we have cos squared x plus cos squared x will be 2 cos squared x. So from here we have sine here and that sine over there, so we can take sine as our common factor, and here we'll be left with 1, and there will be left with 2, and that cos x. Same story, we have cos x here and cos x there, so we can take the cos x as our common factor, and we'll be left with 1 there, and we'll be left with 2 cos x here. So we took one of the cos, and now we are left with 1 cos. So as we can see, this is equals to that, so they're the same. They will cancel out each other, and we'll be left with sin x over cos x, and sin x over cos x is equals to tan x, and this is equals to what we have on the right hand side. So left hand side is equals to right hand side. Determine cos of 75 degrees without the use of a calculator, and we have to simplify as far as possible. So we have cos of 75 degrees, and we have to use special angles to determine this trigonometric, to find the trigonometric value of cos 75 degrees. And our special angles, the one that we can use in this case, 30 degrees or 45 degrees. If those fail, we'll also extend to this 60 degrees. So we have to, so we can see that this 75 degrees will be equals to the sum of those two. So 75 degrees is equals to 30 degrees plus 45 degrees. So this cos 75 degrees, we can write it as cos of 30 degrees plus 45 degrees, because 30 plus 45 is equals to 75. And again, we use our formula sheet, so we'll use this the one that we were using on 1.3, on 1.4 I mean. So this one for cos. So they are saying that cos of A plus or minus B is equals to cos A multiplied by cos B. This was supposed to, so I'm sure if you were to look at other question papers, it will be minus plus instead of plus or minus. Sin A multiplied by sin B, sin B. So it was that formula for cos. So I just copied that formula. So this one is saying, if you have a positive here, if you have a positive like the way that we have a positive, this cos A, cos B, now that you have a positive here, you'll have a negative here. That's why this negative and plus are inverted from those ones. Sin A, sin B. From here, we can see that A will be equals to, so we'll have cos of 30 degrees plus 45 degrees. This will be equals to cos of 30 degrees, cos of 45 degrees, minus sine of 30 degrees multiplied by sine of 45 degrees. So cos of 30 degrees is equals to the square root of 3 over 2, and cos of 45 degrees is equals to the square root of 2 over 2, minus sine 30 degrees is equals to 1 over 2. Sine 45 degrees is also equals to the square root of 2 over 2. So let's see, for cos 45 is equals to the square root of 2 over 2. But if you to use this, the square root of 2 over 2, they will see that you used your calculator. So if we had time, we were gonna use our special angle triangles, and this was gonna be 1 over the square root of 2 minus 1 over 2 multiplied by 1 over the square root of 2. So on our triangle, it's written like this, but on our calculator, it's written as the square root of 2 over 2. But what the calculator did, the calculator rationalized this square root, but on the special angle triangle, these things are not, they are not rationalized, so we have to rationalize them ourselves. So we have 1 over the square root of 2. You multiply this thing by 1, so the square root of 2 over the square root of 2 is equals to 1. 1 multiplied by the square root of 2 is equals to the square root of 2. The square root of 2 multiplied by the square root of 2 will be equals to the square root of 2 squared, which is equals to 2. So I encourage you to use 1 over the square root of 2 instead of the square root of 2 over 2, because it's going to show that you used your calculator. So from here, we have, after we rationalize, so after you write it this way, you have to come and rationalize it. After you rationalize it, that's where you'll write the square root of 2 over 2 minus 1 over 2 multiplied by the square root of 2 over 2. This will be the square root of 3 multiplied by 2. So we have the same square root, so they will multiply each other. This will be 6. 2 multiplied by that 2 will be 4, minus the square root of 2. 2 multiplied by that will be equals to 4. So we have the same denominator. So we add or subtract the numerator. So this sign we will just put it there, and this is, so cos of 75 degrees will be equals to the square root of 6 minus the square root of 2 all over 4. You can confirm this with your calculator, I think. Yes. So you'll know, so you can just write that cos of 75 degrees. You'll know that this should be the answer that you get. So if you don't get this answer at the end, after you rationalized, then you'll know that there is a mistake with your workings. If you have any questions, feel free to leave them in the comment section below, And if you find these videos useful, consider subscribing and sharing these videos with your friends.